Sophos Intercept X with EDR includes the ability to get additional process details. The process details will perform a number of things and gives you multiple options on a tab breakdown. On the first landing page, you get to see the reputation of this executable. Is it well known and manufactured by a legitimate software vendor and signed? Is it somewhere in between and suspect, or is it very similar to malware? This initial indicator can be a very good guide on whether or not you need to perform a block and search for this across other devices. What I want to show here, though, is some information that's available directly from the console so you can see it in action. In this case, Sophos Intercept X has a ransomware detection from ransomgen.exe that was launched from a PowerShell. We've already taken some actions to isolate the computer, and now we're investigating the processes that were involved in the attack. We can see that PowerShell was identified as the root cause. As an administrator, I can take a look at the details of PowerShell, and I can see that PowerShell itself has a very strong known good reputation. PowerShell is actually a part of the operating system. You can see here we've grayed out the option to clean and block it. Removing this from the machine is not advised and can't be done directly through here. PowerShell, though, is on an application control list, so if you wanted to prevent its use by end users, you could. Going back to the details of this report, though, we can see the overall reputation, the path that PowerShell is installed at, the command line that was used during this execution, and we can see more details here. We can see that this execution of PowerShell included a base 64 encoded command string, something very indicative of malware. But again, we're not allowed to put this on the block list. It's a known good system component. PowerShell actually launched the command processor, another known good application, command.exe. Again, you can't clean and block that. Going down the path, we can also see that it deployed a VB script, a memory execution tool, the ransomgen file, and PuTTY. Taking a look for the details of the PuTTY.executable, we can see that it has a strong correlation to known bad. And if we take a look at the report summary, we'll get to see some characteristics that have involved machine learning to compare this executable to millions of other files. So the attributes in PuTTY have a 36% correlation to suspect executables, not very high. Its code similarity to known malware is somewhat high. If the location that it's installed at and was detected on the device is fairly high. Getting more details on that individual analysis, we can see that PuTTY includes the ability to perform AES encryption. It can launch executable shells. It may be hiding some of its imports. It possibly can create other processes. Code similarity says this is an identical match to a known malware, but it also has similar matches to other versions of PuTTY that were also convicted. It is very similar also to a legitimate application. In this case, what I've done is I've taken a free download executable called putty.exe and installed a backdoor in it. It's not surprising that it's similar to the known legitimate application, but the backdoor is what's allowing us to convict it. Its install location is on the user's desktop, which is a dodgy location. If we go ahead and look at the file properties in more detail, we can see that the property of this file indicates that it was produced by a legitimate author, but when we take a look at the exact details for the file breakdown, we can see that it's not signed, that it is including a number of characteristics in PEX imports, so DLLs that are being used, the actual calls in those libraries. Most of these are associated with the known good application. What I might want to do with this before I put it on a clean and block list is search for it across other devices. Going back though to our ransomgen, this is actually a test tool from Sophos. So when we look at its reputation, it's relatively good. It's manufactured by Sophos, but it has characteristics that are associated with malware. So you can see here, it's most similar to Sophos Tester as an exact match. It's just been renamed. This isn't something that we want to treat as malware. It is deployed into a suspect location, though. All of these details are to assist the administrator in taking an action to go ahead and clean and block. One of the most important things to note here, though, is that known good software cannot be removed. These are applications that may be being abused by an adversary to perform malicious activity, but aren't malicious in and of themselves. In this case, we can see that PuTTY has a very low reputation and can be cleaned and blocked and searched for on other devices. This executable mem.exe, if we look at its process details, it's known bad as well. It's something that should go ahead and be treated as malicious. All of this information is available directly by clicking on any of the process or executable file attributes. You can note that process details aren't available for script files. They're not a process. If we go ahead and look at the full attack chain, we'll also see additional executables that were involved here, and they've been tagged. One of them is marked as known bad, and if we zoom in, we can see that the known bad is an executable called dropper.exe. Dropper.exe was launched from the same WS script file that launched our ransomgen attack. And looking at its characteristics, we can see that it has a strong correlation to malware. This is an executable that is going to actually perform a PowerLix attack on the device. It's been identified as bad in this graph, but wasn't prevented from executing because I had it on an allowed list, or I had turned off a policy that allowed the protection. By exploring the capabilities in the process details, administrators get to take advantage of strong machine learning. They get to take advantage of file reputation capabilities. They can even go into details of individual executables. And in the case of Dropper, we see that it has an execution space that's marked as read, write, and execute. This is self-modifying code. This is very indicative of malware. The attribute analysis on this indicates that it has a stack canary, it contains packed code, it manipulates other processes, it examines the disk drives to determine the components available on the system. It's very safe to treat this as malware. If we go and initiate a clean and block, we'll actually terminate any running execution on this device and put it on a blocking list so that all other devices will treat it as malware.